Hey, 7th graders, continuing our look at probability today, we are looking at applying probability to make informed decisions. So, if your teacher gives you a number cube with numbers 1 to 6 on its faces, you've never seen this number cube before, but you're asked to state a theoretical probability model for rolling it once. A probability model consists of the list of possible outcomes, the sample space, and the theoretical probabilities associated with each of the outcomes. You say that the probability model might assign a probability of 1/6 to each of the possible outcomes, but because you've never seen this particular cube before, you would like to roll it a few times. Maybe it's a trick cube. Suppose your teacher allows you to roll it 500 times and you get the following results. Okay, I'm not going to rank those, but you can see the frequency for 1, 2, 3, 4, 5, 6. So if the equally likely model was correct, about how many of each outcome would you expect to see if the cube is rolled 500 times? So if it's correct, you would expect to see each outcome 83 times. Based on the data from the 500 rolls, how often were odd numbers observed? How often were even numbers observed? Odd numbers 228 times, even numbers 272 times. Okay? So another example here, 2 black balls and 2 white balls are put in a small cup whose bottom allows the 4 balls to fit snugly. After shaking the cup well, 2 patterns of colors are possible. Black, white, this is going around in a circle, or black, black, white, white. So Philippe is asked to specify a probability model for the chance experiment of shaking the cup and observing the pattern. He thinks that because there are 2 outcomes, like heads and tails on a coin, that the outcome should be equally likely. Sylvia isn't so sure that the equally likely model is correct. So she found out that the estimated probabilities are 1/3 for the opposites, so black, white, and 2/3 for the adjacent, black, white, white. So therefore, they are not equally likely, and that would be roughly their probabilities. All right, last one here. There are 3 popular brands of mixed nuts. Your teacher loves cashews, and in his experience of having purchased these brands, he suggests that not all brands have the same percentage of cashews. One has around 20%, one has 25%, and one has 35%. So the teacher has bags labeled A, B, and C representing the 3 brands. The bags contain red beads representing cashews and brown beads representing other types of nuts. One bag containing 20% red beads, another 25% red beads, and the third has 35% red beads. So you want to design a simulation to determine which bag contains which percentage of cashews. So your outcome would be the result of choosing one bead from the given bag. Red bead represents a cashew. A brown bead represents a non-cashew. A trial consists of 1 outcome. A success is observing a red bead. Beads are replaced between trials. 50 trials are to be done. So if you were to do this, 35% would more than likely be the easiest one to figure out which one it is, but 25 and 20 would be harder because they're so close together. So you definitely have to look at your the trials that you've done. Very carefully. Okay? So please complete the IXL skill DD.4. It's about experimental probability. So like we did for that first problem, you're going to be finding the experimental probability, which is just the number of times that whatever it is was or happened over the number of times they tried it. So if you picked 8 red beads out of 10 tries, you have 8/10, or simplified to 4/5. Please complete these skills. A lot of you do not do the IXL skills, and they are graded. Because there's so few of them, missing one really tanks your grade. If you need your login, please let me know. Otherwise, complete the skill and have a great day.